Hello and welcome to section 13.6, which is on conditional probability formulas. For any two events, A and B, the probability of B occurring, given that A has already occurred, is the probability of B, given that A occurred, that's how you write that, equals probability of A and B together, divided by the probability of A. And A cannot equal 0. Obviously, you can't divide anything by 0, so that would not work, wouldn't be a real number. So the probability of a volunteer receiving the placebo and having his or her health improve was 20%. What is the conditional probability of a volunteer's health improving, given that they received the placebo? So half of the volunteers received the drug, which is the placebo. So probability of A and B happening. It says the probability of a volunteer receiving the placebo and having their health improve was 20%. So 0.2. And then it says divided by the probability of A, okay? Well, the probability of A is receiving the drug, and so half of them receive the drug. So 0.2 divided by 0.5 is 0.4, or 40%. So there's a 40% chance of a volunteer's health improving after receiving the placebo. Another example of the same type of question. In a survey of pet owners, 45% own a dog, 27% own a cat, and 12% own both a dog and a cat. What is the conditional probability that a pet owner owns a cat and some other type of pet, given that they own a dog? Okay, 5% of pet owners own a dog, a cat, and some other pet. So, what is the chance of that happening? There's a 5% chance. So you could just put 5 out of 100. You could change it to a decimal. So I'll just leave 5% own all of that. So the probability of the whole thing happening is 5%. And the probability of them owning a dog is 45%. So 5 out of 45 basically. So they have a 1 in 9 chance for that happening. Okay. 1 in 9 chance that if they own a dog, they also own a cat and some other type of pet. Conditional probability. So bring that knowledge with you, and we will talk about it more the next time I see you. Have a good night.